In this problem, we are given m squared plus n squared equals to 5. Find the maximum value of 2m plus n. So, when we first see the given condition, m squared plus n squared equals to 5, well, we can think of geometry because this is in the form of the Pythagorean theorem. And this can tell us to construct a right triangle with legs of mn and hypotenuse of 5. We are taking a different approach here than simply solving this using algebra. So, we draw a right triangle with legs of m and n. And then we can call this point as A, B, C, AB as m, and BC as n, and AC is going to be square root of 5. And angle B is 90 degrees. Now, this is just a generic triangle, as there are infinite cases for m squared plus n squared equals to 5. So, without loss of generality, we can just assume that AC here is going to be a fixed side, and angle B, which is a right angle, is going to be a moving point B. So, in this triangle, how do you find 2m plus n? Well, we want to construct the 2m plus n. And the easiest case to do this is to construct a straight line with 3 parts, 2m and n. So, we can construct a line, we can extend the line CB to a point D. So, we call this point as D, and then we connect AD. So, then we can call this as 2m. So now we have a n plus 2m. And now, why did we construct it? Why did we extend CB to the left instead of to the right? Well, this is because we want to form right triangles to calculate the length of the sides. If we were to extend it to the right, we would not be constructing a right triangle here. And it is impossible to find the side length of the hypotenuse. And extending to the left will give us more information about the side lengths. So AD will be equal to the square root of 5 times m by the Pythagorean theorem. Now, how do you find the maximum value of 2m plus n? Since we have a fixed side here and a moving point, well, this reminds us of constructing a circle, where AC is a chord and D is a moving point on the circumference of the circle. And we want to find the maximum length of the chord DC. So we just construct a circle. We only need to construct a semicircle here, as the full circle will not be necessary. Since CD is a chord, well, the longest coordinate in a circle is going to be a diameter. So DC is going to be a diameter in a maximum value case. And the special property of the chord diameter of a circle is that if you have a point A on the circumference of the circle where DC is the diameter, angle DAC is going to be 90 degrees. And now, since we are given that triangle DAC is also a right triangle, we can just use the Pythagorean theorem. We already know that m squared plus n squared equals to 5. And since by Pythagorean theorem, we have AD squared plus AC squared equals to DC squared, we'll have square root 5 times m squared plus square root 5 squared equals to 2m plus n squared. So this will equal to 4m squared plus 4mn plus n squared equals to 5m squared plus 5. And then we can move all of this to one side. So we'll have m squared minus 4mn minus n squared plus 5 equals to 0. And here we have m squared plus n squared minus 5 equals to 0. Call this equation 1 and call this equation 2. We're going to cancel out the terms, so we can add equation 1 and equation 2 to cancel out the n squared term. So these cancels out, and we are left with m squared, 2m squared, minus 4mn equal to 0. 2m squared equals to 4mn. So we can get that m will equal to 2n. Plug that back in. So we'll get that the values of m and n to satisfy the maximum value of 2m plus n are going to be m equals to 2, n equals to 1. So the maximum value of 2m plus n equals to 2 times 2 plus 1, which is 5. And 5 is the answer to this problem.